Okay, lastly, we have number 6 of the free response for AP Calculus AB 2022. Here they have dealing with linear motion. They have a particle. They have 2 particles actually. They give you the position for one, the velocity for the other. They give you initial condition for the velocity of Q. For the position of Q. So first off, part A is asking find the velocity of P. That's just going to be the derivative, which is not that hard. You get 0 minus 4e negative t, but then there's a chain rule times -1, so you get positive 4e negative t. And that's all. That's probably 1 point. Part B is asking find the acceleration, so it's going to be the derivative of the velocity. So you got to do that. And that's 1 over t squared. You can think it's t negative 2 right now. So it'll be -2 t negative 3, which is -2 over t cubed, of course. And they're asking if is the speed decreasing. Well, for speed to be decreasing, you need acceleration and velocity to be opposite signs for that to happen. Well, here's the deal. The velocity is never going to be negative. That's always going to be positive because you're squaring and t is greater than 0. Obviously, you can't have negative time. So we're going to need the velocity to be, so the acceleration to be negative. Well, the acceleration, because t is greater than 0, that's always going to be negative, right? Because you have -2 over t cubed. So it's always decreasing. And so you would just say, for t is greater than 0. And again, velocity is positive, so it's always negative. There you go. That's part B. My guess is that's probably worth 3 points, maybe. 1 point for the expression for A of Q. And then saying the interval where speed is decreasing and justifying it, because velocity is always positive, acceleration is always negative. For C, that's going to be an integral. So you have this. So you're going to have to integrate your velocity function. And we'll have to use our, actually, we could just find the expression first and worry about the initial condition later. So you're going to integrate this. Yeah, because part C is asking you to find the expression for it. So that's integral of t negative 2 dt. Excuse me, that's t negative 1 over -1 plus c. That's going to be your position function. Or -1 over t plus c. Now you're going to plug in the initial condition. So you're going to have 2 equals -1 over 1 plus c. So c is going to be 3. So your expression -1 over t plus 3. That's part C. And then lastly, for part D, we're at home stretch here. Which particle eventually be farther from the origin, P or Q? Well, as t approaches infinity, right? So if you think about it, for x p of t, we're just going to say it's 6, and here's the reason why. You have 6 minus 4, and now that's going to be on the bottom because it's a negative exponent. So when t is large, you have 4 over infinity, which basically goes towards 0. That's why you get 6 for x p of t. For the other one, for y q of t, that's going to be 3. The reason why that's going to be 3 is, remember what we got earlier. We had -1 over t plus 3 from part C, right? And if you put infinity on the bottom, that's just 3. So it's pretty clear that P is going to be further from the origin. But when T is approaching infinity. And that's that. Those are the solutions for the AP exam.